I want to show you about scattering of light and Tyndall effect. These two activities I want to perform. So first let us try to understand what is scattering of light. I have a laser light with me. So let me switch it on. If I switch on, you can see on the other wall a dot.
Yes, sir.
Can you see a dot?
Yes, sir.
Okay. Now come back to this. Can you see the path in which the laser light, the red light traveling?
No.
Can you see the path? No, it is not seen. Only you can see the dot over there. Okay. Now the question is why? What is the reason? What is the reason? So to explain this, what is the reason, to answer my question, I have taken a bottle here. In this, already I have filled in some smoke in this. Some smoke I have filled in.
Yes, sir.
And then I want to focus the same laser light somewhere here, like this.
Yes, sir.
Oh, yes.
Look at this. Can you find the path now?
Yes, sir.
Can you find?
Yes, sir.
Okay, good. We'll answer all this a bit later. But first try to observe. Can you see the path of the light here?
Yes, sir.
Okay, fine, good. I want to do one more small activity to show the path. So here, I can call one boy here. Tarun, please come. Please come. Now I have collected some chalk dust particles, chalk dust on this, chalk dust. Now what Tarun is going to do is, he is going to blow air here. Okay?
No. Yes,
Can you see the path? Okay, let us collect some more dust. Yeah, wait. See, he is going to blow the air once again.
Yes, sir.
Can you see?
Yes, sir.
In the first case, I have collected some smoke in the bottle and we could see the path of the light. And here, because of this dust, and you can see the path of the light. And similarly, whenever in the house, maybe in the morning time or in the evening time, what happens is, when sunlight falls through the window, can you see the path of the beam of light?
Yes, sir.
Even in that you can see the dust particles.
Yes, sir.
Right? So all with these activities, now I am going to introduce this scattering of light. Okay? Let us suppose this is the light. This is the light which comes from this direction. And previously I have taken here, I have taken the light, and here we are unable to see any light. The reason is, in between there are particles. There are particles in the medium, but the size of the particle is very small. Since the size is very small, though the light is interacting with it, it's not getting deviated from its path. But when I take the dust particles or the smoke which is captured in this, what happens is, the size of the particle is increased. The size is increased. Here the smoke particle size is increased. It is more compared to ordinary air particle. Then what happens is, this light, after striking that particle, then what happens is, it is getting scattered or deviated from its path and it has gone in different directions. This process of light getting deviated in different directions due to interaction of the particles of the medium is known as scattering of light. So that light, whichever is scattered in all the directions, has entered in your eye and we are able to see that light. This is what is happening. To explain this, I'd like to take one more small activity. Now look at this. I have taken two beakers. There are two beakers. In the first beaker, there is water, pure water. And in the second beaker, is it not looking a bit of milky?
Yes, sir.
What did I do is, I have dropped some Dettol in that. I have taken Dettol and then I have poured some Dettol in this. Then what happens is, now this has become a Dettol solution. And Dettol particles, they will be hanging in water. And that is called as colloidal solution. Whenever particles, they hang in a solution, we can call it as colloidal solution. So I have taken a colloidal solution to my left side, and here this is pure water I have taken. Now observe what you can see. Okay, just observe. Just look at this. Did you observe any path here in the first one?
No, sir.
Did you observe the path here?
Yes, sir.
Right? Did you see this?
Yes, sir.
Then can you guess what is the reason? In case of this beaker where Dettol solution is taken, it is colloidal solution, means particles are there, they are hanging in water. So whenever this light goes there and strikes, the size of the particle is a bit more, therefore it has been deviated from its path. There is a scattering effect. So the scattering effect in case of colloidal solution is generally called as Tyndall effect. What is it called?
Tyndall effect.
Tyndall effect is a scattering effect. In general, we take colloidal solutions and we see the scattering phenomena over there. Can you see the path in this?
Yes, sir.
No, in the first beaker?
No,
No,
sir.
sir.
Why not? One person, please tell.
There is no dust particles.
No. Anybody else?
It is not a colloidal solution.
Okay. Any more answer?
The particles in the first figure is very small.
The size of the particles, the size of the particle is small, very small. So here, in case of this, that is the colloidal solution, the size of the particle is a bit more. That's why we can see that scattering effect. Is it fine? So with this concept is over. Thank you.